Yes guys, today we're going to be trying to prove the ratio lemma. And the ratio lemma is this. So we have AB over AC is DC over BD multiplied by sine BAD over sine DAC. It's sort of weird that we've got multiples. We've got DC there and DC there and BD there and BAD there. Sort of weird how they're across each other, but it's a useful ratio property for when trying to work out AB over AC. And AD here is a Sibian, so that's just a line segment from a given vertex to the opposite side. So we see sine, so I'm tempted to prove this using the sine rule. So if you look at triangle ABD, well, we obviously want an angle with BAD and DAC, so let me just label them. BAD and DAC, let's label that there. But for sine, we have to obviously choose two lengths and two corresponding angles. So it makes sense to choose this length here because this is where DC and BD form a property join up. So let's choose these two angles here. So for triangle ABD, so sine of angle, sine of BD or ADB over the opposite length, so that's AB, equals sine of, now we're using BAD as per the proof, all over BD. So that's all we can pretty much do with this triangle. I mean, we could work with this angle here, but it doesn't really spare us anything. So let's move on to the next triangle. ADC or ACD. ACD. So now let's take the other angle at D, so sine ADC, sine ADC over that length opposite, so that's AC. The reason that's useful is because we get AC from the property, ratio property. And that equals, now we involve the angle from the property, so sine DAC, and that is obviously opposite DC. So to merge this all in one, you can divide, multiply, plus or minus, but adding and subtracting won't really be of any use because we'll have too many angles and lengths. So we should either multiply or divide. Well, multiplying obviously won't really get rid of anything. There's not really cancellations going on, but if you divide 1 by 2, that's seam-wise. Yep. So we have sine ADB over sine, which is right there, 1 over 2. We have sine ADB all over sine ADC, ADC, that's right. And then we also have 1 over AB times, or divided by AC. So that's 1 over AB divided by 1 over AC. So that's AC over AB. AC over AB. And now the next part, sine B of A over D, and that's divided by angle DAC. This is looking good, as that's what we wanted in our proof. And then we have DC over BD. DC over BD, so that's also looking at a proof. Right. So from here, we need to sort of simplify this. Well, one good thing to note is that these two angles here, BDA and ADC, BDA and ADC, so these two angles here, they add up to 180. So if we call this angle X, this angle here must be 180 minus X. And we know since ADB equals ADB plus ADC equals 180. We have ADB equals 180 minus ADC. So we take the sine of both angles. Sine of ADB equals sine of 180 minus ADC. So now we've got this right. If let's say see this as x, 180 minus x, we can just say that these are the same angle. Yeah. So these two can simply just cancel. So we're left with AC over AB equals DC over BD sine BAD over sine DAC. And is that what we wanted? Let's have a look. I believe I just made a mistake writing this out. This should read, well, we should have AC over AB here. AC over AB equals DC over BD. Yeah, that seems a lot more right. So we have AC over AB is DC over BD. Or alternatively, we can just write this as AB over AC equals BD over DC sine BAD over sine DAC. Times. And what we got down here, AC over AB equals DC over BD plus BAD over sine DAC. Yeah, so we got the first one. So that's this ratio lemma proven. And just a quick thing to add, right? If our CBN here was a median met at the midpoint of BC, so it's sort of like a median, then these two angles here would be the same. Now if they're the same, that means sine BAD, sine DAC, or sine of the same angles is again just equal, so they would just cancel. So we get the property that, it's right here in blue, if BAD equals, actually right, if AD bisects, so splits the angle in half, angle 8.5. If AD bisects A, then AC over AB equals DC over BD, or AB over AC equals BD over BC. Obviously because the angles are equal. That's it for today. Hope you learned something new. It's a pretty niche ratio trick, and look forward to producing more content like this. Goodbye.